In this video, we're going to calculate the limit of this function as x approaches to infinity and minus infinity, and we're going to discuss horizontal asymptotes. Okay. So first, we're going to calculate the limit of x over x squared plus 1 as x approaches to plus infinity. Well, the denominator has x squared in it, so we will divide the top and the bottom by the highest power of the denominator. So we're going to divide by x squared by x squared. Okay, that gives us the limit of x over x squared divided by x squared over x squared plus 1 over x squared as x approaches to plus infinity, which equals the limit of 1 over x, 1 over x squared as x approaches to infinity, and the limit of 1 over x as x approaches to infinity is 0. The limit of 1 is 1. The limit of 1 over x squared is 0. So this gives us 0 over 1, which is 0. Okay? So the limit of x over x squared plus 1 as x approaches to plus infinity is 0. This means that the line y equals 0 is a horizontal asymptote. Okay. Let's do the other limit. The limit of x over x squared plus 1 as x approaches to minus infinity. And again, it's the same procedure. X over x squared and x squared over x squared, 1 over x squared as x approaches to 0, to infinity, negative infinity. Once again, what we look at is always the denominator, and we look at the highest power in the denominator, and that's what we divide by. That gives us 1 over x, 1 over x squared as x approaches to minus infinity, and when x approaches to infinity or minus infinity and you have a constant on top, this goes to 0. Okay, a constant over x goes to 0 as x approaches to infinity. Once again, we have the limit as x approaches to minus infinity equals 0. This also confirms that the line y equals 0. If it was a different one, we would write the same thing, we would have had a different horizontal asymptote. Okay. If I can briefly draw the graph of this function, it's going to hit 0 when x equals 0, because if you put 0 in here and 0, it gives you 0 over 0 plus 1. So at x equals 0, the y value is 0. When x is positive, this is positive, so it's above the x-axis. When x is negative, since this is negative, the whole thing becomes negative because this is always positive. Okay, so, and it approaches to 0 as x approaches to infinity. So it looks like, let me use a different marker, different color. So it is positive, but it comes down to 0. And it is negative, and it comes down to 0. And you can also see that this expression is symmetrical about the origin. So if you apply the symmetry, you can see that it's kind of like a mirror image reflected twice, once through the x-axis, once through the y-axis.